Yes, ma'am.
And how we are going to test the seeds quality? What are the main important parameters for testing the seeds quality?
No, we don't study in that history. Just seeds like germination and treatment.
Coming to seed quality parameters, it mainly contains seed moisture content, physical purity, germination, and growth test. These are the four concepts we are going to test in mainly here for the technology means for maintenance of seed quality. First of all, when we produce the seeds, we undergoing this, we'll be harvesting, threshing and all. So during harvesting, threshing, what happens is wheat seeds and other seeds, other crop seeds will be also be harvested and threshed at the moment. So first importance will be given for physical purity. And in physical purity we have main crop, that is when we go for many horticulture crops or many crops. The main pure crop will be the crop which we are intended. Means giving paddy, sunflower, tomato, and next category pure seed and other crop seeds. Other crop seeds means if we have threshed any other crop, if we thresh again on this same ground without cleaning it, what happens? The seeds of this also get mixed. So pure seed, other crop seeds, and next is the wheat seeds. Wheat seeds and inert matter, four categories will be classified in the seed quality, physical purity. In that, what we will do?
See, I told you about foreign organic matter, how it gets into that.
Yeah.
That this is part of what we do.
Yeah, foreign material may be other crop seeds, or leaves, or inert matter, soil matter, and any debris also can be other pure impurities in that matter. So, in all the crops, we will be having at least 99 to 98 to 99% physical purity should be there to be considered as a seed material. Because if we carry all those things, the same wheat seeds and other crop seeds will be carried over to the next generation also. So, the farmers will be forced to remove the wheat seeds and other seeds for maintenance of purity. Thus, maintenance of purity is the main importance for seed production. Ordinary production means you can do for grain production, but for seed production, physical purity is the main important parameter. And next coming seed moisture content. Seed moisture content means in the seed moisture, if it is more, we can't store it for a long time. So fungal attack, bacterial attack, molds will be there. So we can't go for storing a longer period. So the seed moisture content is also a important parameter other than physical purity, seed moisture content. And next coming the germination, most important parameter. The germination should be around 90 to 95%, which we add to cellulic acid seed. In seed we have
Not much in detail, ma'am, but seed germination.
we have classes of seeds, means nucleus seed, breeder seed, foundation seed, certified seed, and truthfully labeled seeds. And all this breeder seed and nucleus seed will be coming under the purview of breeders. Means the person who has developed that variety or maintaining that variety, he will be looking after nucleus seed and breeder seed. Next will be coming foundation seed, certified seed, and truthfully labeled seed. Foundation seed and certified seed are considered we have Karnataka State Seed Certification Agency. Yeah. If you want to be certified seeds of classes, we have to register with them so that we can have foundation seed and certified seed. And truthfully labeled seed
draining from water outside your soil. So there are from there the filtration is utilized by the plant. How will the filtration plant and the water is continuous circulation so that there is an optimum water air flow and the roots also propagate to the plant. This is the like a still in working on. One more type of hydroponics, that is one more type of soil structure.
Okay.
Here we are not using soil. Instead of that, this light medium we are using. This is called hydrodome. Hydrodome.
So light, it looks like stone, but it's not stone.
Right, it looks like stone, and it also absorbs more water, and it's also light and better development of a root and also good root arrangement. This is prepared by just like expands popcorn, just like that. Expanding it like hydrodome or expanded clay. The clay balls we will be expanding it, heating it for 180 or 200 degrees Celsius, and the clay will expand. Here we will be providing the nutrient solution directly to root zone twice a day. It also depends on the crop which you are growing. If the crop is highly nutrient exhaustive, we will be providing more nutrient. Optimum is like a full set population. So it's an open system. It's an open system. Water is circulating continuously. Water goes to tank and marine here. But this is an open system. Once the water gets drained, it drains out. It's a closed one. This is called ebb and flow or plug and drain system of hydroponics. Here the water gets flooded into the table. On this or no sir, it will cut it till here and then there is and once the water is into the table, the whole site is like a media is media by and that's the vertical film hydroponics. Here the water will be continuous suction and the water flows in the form of film inside. This pipe and then again from there to here and then and to the tank and again it gets circulated. This is also closed system of hydroponics. Once we fill the solution into ebb and flow is also closed. This is also closed and this deep water or aquaponics that's also closed. Only this bucket is open. Here we will place in this the ceilings absorb the water and grow.
Let us know.
This is the vertical tower hydroponics. The hydroponics tower. Here, this is the reservoir. Here the nutrient solution will be stored, and from here, from this pipe, the water gets sprayed like not a mist. It gets sprayed over the tank, and from there to here, and it also it flows through all the root zones, and it gets collected, and again it is pumped to the top, and it is then the pipe.
ಒಳಗೆ ಕೂತ್ಕೊಂಡ್ಬಿಡ
Third year. Part of the plant and propagated. Which has the most.
So after drying, we can estimate how much was the moisture in the seeds.
I explained to you loss on drying. How we calculate. That is
Loss
the method.
initial weight minus the dry weight, and we get the moisture weight. In this we have mainly two methods. That is high constant temperature means 130 degrees for 1 or 2 hours, depending on the crop. For mainly oil seeds and all, we go for 1 or 2 hours. For grains and all, we will be very hard. So we take 17 hours for 1 or 3 degrees. This is 1 or 3 for low, 130 for high. Temperature 130 at the time 1 or 2 hours, here 70 hours.
The father of plant tissue culture, the bust. Only the half is there, no? That is the bust, Botanical Haberland. When the whole part is there, that is statue. And that is only the above part is there, that is called as bust, BUSD. So that is Gottlieb Haberland, father of plant tissue culture. And the people we are seeing here today, DNA model, and those two, Murashiki and Scoop, they are only named after the media. Whatever the media we are preparing here for the plant growth, that is called as MS media. What and all nutrients are required by the plants for the growth?
Micro and macro. NPK.
Macro, micro and vitamins also. So we'll be preparing the solutions, micronutrients, and there will be solutions of iron stock also. It comes under micro also, but separately we do prepare iron because of this iron. It oxidizes readily. and it comes in contact with the air. So we are supposed to prepare it separately and we'll be storing it. Next is vitamins. Vitamins also is required for the plants. So those 4 stocks we'll be preparing. From those 4 stocks, the media which we prepare will check the pH of the media also. It should be certain pH is required for the plant growth tissue culture. So that will be 5.6 to 5.8 pH, what we are maintaining here. The main which we are maintaining here is 5.7. So and this, how do plants get carbon dioxide inside the water? What source should be added so that the plants can take up the carbon dioxide inside the water? We'll be adding the sugar, the carbohydrate source. And did you see the cubites are found inside? That is called as growth room where we'll be storing our water for the growth. Can you see the media? The media, it is jellyfied media. We are adding agar-agar. So start from red algae. So this agar-agar will be using 6 grams. You know what is the cost of sugar? Sucrose? Not sugar, sucrose. Sucrose will cost us around 1.5 to 2 kg. So we are not using sucrose, we are using the normal sugar only. Normal sugar only we are using from since like 2006. We are using sugar itself. So instead of sucrose, the sugar has been used. And the agar also. When I go for the lab grade high media, there's high media laboratories here. Whatever, they will be providing the chemicals, it is too costly. So if at all I take agar from them, it will be 10,000 per kg. So I am taking from some other lab, bio lab. So they are giving it for like 2.5 kg. So I am not using this the costliest one. We are trying to cut short on the cost while preparing. And this media, it will be autoclaved also. We have used autoclave, right?
Yeah, sterilization.
What is that? The principle of autoclave?
Moisture. Sterilization.
What will be the temperature and pressure?
115 for 15 minutes.
21 degrees centigrade.
For 15 minutes.
15
LBP.
units. That 15 minutes, we are not going to 15 minutes. We are going for 20 minutes for empty bottles. If media is there, it will be 22 minutes. And if I am preparing sterile water, it will be from 100 ml to 180 ml. So I will be increasing the sterilization time for 30 to 45 minutes. And we don't use this petri plate here for culturing. We are using some brown papers which we sterilize in a cover. So that is biodegradable also. To save the time, if at all I am using petri plate, I should clean the petri plate, I should add alcohol, I should flame it and I should wait for it to cool down. So this time can be saved by using the cut-size brown paper. We have seen the label of this binding sheets will be there. Same only I will be getting from
Graph paper.
the size which I need. That will be cut and it can be used like multiple times, not multiple times. The cover can be used multiple times, but by using that, we will be saving the time. And even, what is the main purpose?
Why did it cells?
Contamination, to reduce the contamination. If at all you are using petri plate, you are getting more of contamination because you are using the same thing. But when I am using paper, I will be using a different paper from the same paper. The contamination will be like 90% it will be reduced. If at all you are getting 50% contamination by using the paper, 90% contamination will be reduced. And you know about micro-propagation stages. Can you tell me plant tissue culture properly? What do you think? I just told so many things now. What is happening in plant tissue culture?
Yeah,
Callus.
undivided cells. Which can be.
My question itself has the answer at the starting.
Callus.
Culturing of
Callus.
plant tissues. Plant tissue culture means culturing of plant tissues on a known nutrient media, the MS media, under controlled conditions. What are the controlled conditions?
Temperature.
The temperature,
pH.
the humidity,
pH.
even the humidity. We are supposed to maintain 100% humidity inside this bottle. This will be fully tightly closed. So 100% humidity will be there. If at all air is going inside in the sense,
Contamination.
humidity will become less, contamination will be more. And even the temperature, if
Microbial.
at all 18 degrees maintained in growth room for a whole month, what can happen inside the growth room? If at all you are maintaining 18 degrees. Low temperature of 18 degrees. What can happen? There will be vapors here in the bottle. There will be vapors. And there will be full of fungal growth because you are maintaining the 18 degrees. So the temperature of 26 plus or minus 2 should be maintained in the growth room. Otherwise, if it is more, the plants will die. It will dry up. If it is becoming less,
And then
fungal contamination. Fungal growth will start not in the media. Wherever the vapors are there, contamination will be there. And this is callus from jasmine leaf, Mysore tree. There is like a stages called as somatic embryogenesis. Have you heard about it?
Yes.
What are the shapes which will go under somatic embryogenesis? If at all I am getting directly the shoots from whatever experiment I am keeping, that is called as
Shoot.
direct organogenesis. But if at all I am getting callus, then the plant, that is indirect organogenesis. But in this somatic embryogenesis also one topic is there, where you will go through certain embryo shapes. It will be in globular shape first. After the callus should form to a plant, right? Through that plant, when it forms, there will be some stages. That is called as globular stage. Next will be heart shape. The embryo, it will form a heart shape. Then it will go for torpedo. At last, cotyledonary. This is indirect somatic embryogenesis. In some cases, when you keep a leaf, there will be no callus. is callus. From callus, it will be from there. So here, yeah, it will be there. Here, I have placed the leaf, but there was no callus formation. From leaf only, from getting from node and meristem, shoot it, that is fine. But when you place a leaf, mostly you think you should get callus only. But when you place a leaf, you get directly the shoots. This is leafy and this flower pot. This is direct flower. There's no stages. These are from seeds, citrus species. Are they prototype? Seeds, like plant. These seeds. When you place a seed, it will be like that. It can be like that. But when you place a seed, you are getting so many. It is not prototype. So you can't say that whatever seeds you are doing, that will be prototype. But if at all you are going with nodes, meristem, that will be prototype. In case of banana, what do you think we will take as an explant?
Stem.
Roots.
Stem or root?
Stem.
Not root? We need both root and stem for banana. This is G9 banana. The black color, whatever you are seeing below, that is the root part. When I take, I will be uprooting the whole sucker. Have you seen the sucker? Have you heard about the sucker? Banana sucker? Have you seen
It is the
banana plant?
vegetative propagule.
Have you seen it? Have you seen the banana plant?
Yes, ma'am.
Whatever the shoots you'll be seeing surrounding the banana, that is called as daughter sucker. The one which is moving with the mother plant, surrounding is called as daughter sucker. And banana is not a true stem. It is just wholes of leaves. So that is a pseudo stem. So it will be the meristem, the apical tip. In most of the plants, it will be an apical. But in case of banana, it will be attached to the root. It will be starting from the ground level. Meristem will be inside, deep inside. So I will be uprooting the whole sucker along with the soil. It will be inside. The sword sucker, in which there will be bulge the rhizome part. And the stem will be, it will come up like a sword and then opens up the leaves and the leaf also will be narrow. It will not be broad. So I will be able to see that sucker as sword itself. Sword it is called as sword suckers. So these suckers will be taken after harvesting. Will the farmers allow us to take the suckers before harvesting? What all we do so? The bunch will be wasted or else it will not mature. So after harvesting and only first crop, not the raccoon crops. You know about raccoon crops, right? The next crop is called as raccoon crops. I will not go for raccoon crops. I will be going for only the first crop to get virus-free explants. There will be so many viruses and diseases in banana. So I should go for only first crop and healthy plot to collect the suckers. It should be disease-free and high yielding. These are the things which we tell to farmers. It's disease-free and you will not get any disease. The yield will be more. Whatever we'll be telling, when we go for the explant collection, these things also should be there in that plot. So we see to it so that when we tell to the farmers, so we can say like we'll be confirmed that whatever plants we are giving, that will be fine in the field. So next, this banana shoot. Are you seeing only one shoot? Like how when you plant a plant, there will be so many shoots surrounding, like that only it's there. There are like 10 shoots also in one clump. This clump, 1, 2, 3 clumps. So many shoots together forms clumps. This bottle, when I go for next subculture after 1 month, this will become 3 bottles. These 3 shoots in one clump, I will cut and keep it. Next the 3 shoots will be there, it will become again 9 shoots. So this goes on multiplying. So whenever I make only one sucker, I can produce 500 plants from that. But this takes for 1 year. This stage is called as micropropagation stages. Where you will be having stage 0 as explant collection. Stage 1 will be doing the initiation, sterilizing the explants. You will be uprooting the sucker, so sterilization is necessary because contamination chances are very high. So you will be using so many sterilizing agents like contact fungicide, then systemic fungicide, sodium hypochlorite, mercury chloride, antibiotics like streptomycin, tetracycline. These things will be used. The whole process takes for around from 9 hours. And per day you can initiate only 100 suckers, not more than that. So out of 100, we can get some 5 suckers contamination. Whatever we do, it will be there because some rhizome will be having that bacteria in the feed itself, which we can't take away from sterilization process. So we can't take out some of the contamination from the sucker. So that we will be getting contamination here. After initiation, this is like multiplication. Stage 2 will be multiplication, where you will be multiplying. Then comes stage 3, rooting. Rooting. This is the subculture stage. From this, you will go for 7 cycles. Up till only 7 cycles, not more than that. Because if at all you go further after 7 cycles, you will get somoclonal variation. That's what. If at all those somoclonal plants are given to the farmers, they will not get proper yield. So we are not supposed to go further after 7 cycles. Means 1 bottle is there, after 1 month you will go for 1 subculture, again after 1 month you will go for 1 subculture. That is called as 7 cycles. So somebody might ask how many cycles can be done in banana. This is called as 7 cycles. In case of G9 banana, but in Yelaki banana you can't go for 7 cycles. Once if at all you are getting multiplication ratio, it's of use for going till 7 cycles. But when the subculturing, the ratio stops at 5th subculture in Yelaki. So it's of no use when you go for further cycle. So you'll stop at 5th cycle only. So rooting, can I see the media's black? What I have added? Charcoal. Activated charcoal. Why charcoal? creating artificial environment by adding this charcoal. What artificial environment is being created by adding charcoal? Carbon, right? The sugar absorbing the artificial environment for the plant. I am giving. So what is that? What is that? I'm telling you, I'm adding charcoal to create the artificial environment.
Water only.
Does the sunlight deeply penetrates inside the soil for the roots? So I'm just creating the dark condition for the root growth. It is an antiphenolic compound also. Along with that, you are just creating. I'm telling you, whatever we do, that will be artificial environment we are supposed to create for the plant growth. So by adding this charcoal, I'm just creating the artificial environment so that light doesn't penetrate and darkness will be there for the root growth. But now, can you see the roots? There are so many roots. So this is the stage 3. After stage 3, what I'm supposed to do? Stage 4, acclimatization. It will come outside the lab for hardening stages. First stage is called as primary hardening stage, where I will be doing in a portrait. There will be small cavity hole portraits will be there. In one portrait there will be 98 holes. So in that I will be planting this. And can I keep the portrait outside now? I'm not supposed to keep it. I will be keeping inside the polytunnels, in closed condition, where I will be maintaining 100% humidity. So for 1.5 months the portraits will be inside the tunnel, and for 15 days there will be no watering. And after 15 days I will water it. For 3,000 plants only 10 liters of water. You should not water more also, otherwise it will start rotting. So you should water how much water is required for the banana plants. Remaining you can water, but the small plants will be there. For other plants also you should not water so much. So after 15 days, every week there will be watering until 1.5 months. 4 to 6 weeks is required for hardening, primary hardening plants. Then later it will come for secondary hardening, where I will be using medium mixture of sand, soil and cocoa. The polybacterial in our plant will be given. So that is the mixture which I will be using. 1:2:1 ratio. Red soil will be 2 ratio. Sand and cocoa will be 1 ratio. And in that I am supposed to plant this. Whatever primary hardening plants will be there, and transfer to the secondary hardening. They also it will take 1.5 to 2 months for hardening. And I can keep the plants only up to 3 months, not more than that. Age-old plants should not be given to the farmers. Same thing, the variation will start coming. At time to time, it should go to the next stage and it should go to the field at the proper time. You should not keep the plants for like 4 or 5 months. By within 3 months, the plant should go to the field condition. Otherwise, you will not get the proper yield. This is an orchid. Orchid. Flower. What is the explant for orchid initiation? This is banana. What can be taken for orchid?
Aerial plants. Leaves aerial.
Have you seen the flower?
Yes, ma'am.
Have you seen it forming into a seed? After pollination. It will form into a pod structure, POD pod. So that pod will be having more than thousands of seeds. So at last it will form into a pod structure which contains so many seeds. From seeds, how many plants it can produce? From one pod.
Minimum 5.
Pod will be having seeds, and those seeds will be in millions. The powdery form, the seeds, it will be in powdery form. It can like produce millions of plants from the pods. So whatever that powder form will be there, that will be like initiated. Now we can see the growth is there. It was not earlier, it was not visible also, it was powdery form. This is like 3 months. It takes a very long duration and the easiest initiation procedure. There is no using of sterilizing agent. You will just dip it in alcohol, you will show it to the flame, you will cut it. The seeds are inside the seed coat. So no need of more of sterilization process. What is the cost of per plant of orchid? You might take it online. It will be 1,000 rupees per plant. The flowering plant, that flower stays for 2 to 3 months after flowering. So that is the costliest plant. Apart from that, there is one more plant, anthurium also. And even anthurium also can be produced in a large scale. So apart from banana, there will be anthurium, orchid, gerbera, these things going on, the culture. And we do create here salt tolerance and drought tolerance in culture. For salt tolerance, I'll be adding different concentrations of salt for the vegetable crops when we do. What about the drought? Drought. How can I create drought tolerance?
Growing water.
Patient
Are we using the same medium?
Nutrients.
I'm supposed to add some chemicals to create that drought, that is called as PG, polyethylene glycol. So by adding that, you'll be creating the drought tolerance in the vegetable. This is mescaline. So this is basal media. There is no PG here. Some seeds. But is this sugar type? When you culture it, when you are getting the plant, by that time you can tell whether that is fruit type or not. Only one is coming with that will be 300 bottles, not 30 will go for 300 bottles. Like this I told, in one pot you can produce millions of plants. But in the environment the seeds doesn't propagate properly, the orchid. But tissue culture you can propagate each and every seed, the powdery form the seed will be. This is orchid. And in tissue culture you can grow inverter flowering also. When you have kept the plants, it will grow and there will be inverter flowering also. Till now I have seen only rose and orchid, even the cucumber also. Inverter flowering also. Do you know about grafting also?
Yes, ma'am. You cut the stockings here.
In tissue culture there is like micro grafting. Cutting the shoots and you see grafting there inside the laminar airflow. And whatever cultures we do, we are supposed to do only in
Aseptic.
that is laminar airflow. You have worked in laminar airflow, right? What is that? The principle that works?
Filtered air inside.
What is that filter called?
HEPA.
What is it? HEPA?
High efficiency particle.
The diameter of the filter?
0.25.
0.2 to 0.3 micrometers. So before it goes to the HEPA filter in the laminar airflow, there will be one more pre-filter.
PP
also.
filter.
So first it goes to pre-filter and then HEPA filter.
UV light.
Pre-filter we can ask other person to wash it, but HEPA filter we are supposed to change it once it is not working. And the HEPA filter efficiency can be known by one more meter will be attached to the laminar airflow. Have you seen it? The monometer. There will be some oil level will be there. When you on it, it will go. From that monometer you can see the efficiency of HEPA filter. Once the HEPA filter is not working properly, whatever culture you do, everything will be contamination. So by that monometer only you will get to know whether your HEPA filter is working fine or not. And what you are using for sterilization of forceps and scalpel? We will be using forceps and scalpel to cut the exposed
Red heat.
gold.
Red heat. Flaming.
But here we are using this glass bead sterilizer. There will be a steripot in which we will be adding glass beads. So the temperature inside that will be 265 to 285 degrees centigrade. So within 10 seconds, whatever instrument will be there, that will get sterilized. So this is one more thing by how you can reduce the contamination. The forceps and scalpel will be sterilized properly. So most of the we are using this glass bead sterilizer now. Anything else?
We would love to see inside, but
We can't allow you.
we are disappointed.
Laboratory for medicinal and aromatic crops. This is the, I will explain what are the instruments one by one. This is a hydro distillation unit. We are using for extraction of essential oil from aromatic crops. Here we put planting material and immerse in the water and we give the heat. After some time it starts boiling and the water molecule extracts the oil content within the planting material and it's converted into vapors. That vapors passes through these glass tubes and it enters into the condensers. This is the condenser and condensation takes place and condensation it forms the liquid. And based on density, oil and water droplets form a separate layer. Oil will collect upper and water will collect down. After that we separate both. And this is the steam distillation. This is also used for essential oil extraction. Here we are using water and we are using here steam. This is the steam generator. We put the planting material here. The steam is passes through this pipe into the planting material. Here condensation takes place first. The vapors, that steam converted into water. Afterwards, that water droplets extract the oil from the planting material and then converted into vapors. That vapors enters into condenser. This is the condenser. Condensation takes place and then oil we will collect. And this is the another apparatus, Soxhlet apparatus. Soxhlet apparatus is mainly used for extraction, plant extract. Soxhlet. After that, for this we are using different solvents, methanol, hexane, petroleum ether. For that, we have to separate the plant extract from the solvent through the rotary evaporator. Plant extract. After that, plant extract we have to analyze for quality and quantity through HPLC, for high performance liquid chromatography. This is the HPLC system. It's manual only. Here we have one project related to Panchavalkar. That's a Panchavalkal. I think you pharmacy people don't know. Panchavalkal is one type of treatment. It includes 5 species: Ficus bengaliensis, Ficus racemosa, Ficus virens, and Ficus. Another one is Thespecia purpurea. All these plant formulations used for Panchavalkal treatment. We have one Panchavalkal project. We are extract the bark sample from different locations of these 5 plants. We extract through Soxlate and we analyze for quality and quantity. High performance liquid chromatography. Mainly it is used for quality and quantity. This peaks indicates some bioactive compounds presence within the plant extract. That area indicates how much concentration. We have to compare with standards. If here we are using different standards. Capic acid we are using for Ficus bengaliensis. Comparison with that capic acid, we have to take the standards, compare with what is the concentration is within our plant extract. We are getting from bark sample. We have to compare in different seasons. Okay, compare. These are the products from different aromatic and medicinal crop. We are extracting essential oil. We have a different aromatic essential oil. We have a training program for women. They made aromatic candles and decorative candles. These are the different products we prepared from medicinal crops like hair pack, hair oil, and face pack. These are the soaps we prepared from aromatic and medicinal, both organic.
Do you conduct training programs for this?
Yeah.
Here also?
Here.
Those interested
Those
in cosmetics and these candles.
Candles. For that also we have women's training programs. This is the squash, the concentrated juice. We have more shelf life than normal juice. You can dilute it and drink. It is made from medicinal crops. Like this is the powder of tulsi. This is stevia powder. Stevia used for diabetic patients, sugar patients. This is ginger powder, amla powder from different medicinal crops.